Hey everyone, so this is the last video for CSC 223. I hope everybody had a great semester, and I know you all learned a lot and your brain probably feels crammed to the brim. Studying data structures and algorithms will do that to you. But yeah, I think as you decompress over winter break, you'll really start to feel some of this stuff sink in, and really this is just the beginning. You'll want to keep learning about new data structures and new algorithms as you continue along in your career or your undergrad education. So let's talk about this final graph assignment in which you are connecting various airport nodes using an adjacency list, which you have in a text file that looks like this. I created a sample application for you all to help with the project, and if you would prefer to figure it out on your own, by all means don't watch the rest of this video. This is just for people who want to know how I would approach the problem, but I'm not giving you the solution. I'm giving you a program that works on a different data set. So we have here an adjacency list which represents a graph of cities in Virginia with distances. So for example, we have Roanoke here and just some estimated distances by road. So Roanoke is a node, and its neighbors are Richmond, Charlottesville, Stanton, Martinsville, Lynchburg, and Christiansburg. And these are roughly the distance in miles. So very, very similar to your assignment for this module. And I can show you, well, I will post this code in Canvas to help if you're stuck at any point. Again, this is completely optional. If you want to do it on your own and you don't like spoilers, you can just ignore this video. But to read in the file, I have a simple main method here in main.java, which uses a custom method I developed called read text file based on the file, and all you have to put in the parameter here for this method is the name of the text file. So it will be different in your case, but let's find this method and see how it works. So we will open declaration. Guess that didn't work for some reason. Get this out of the way. Okay, so this is our read text file method, and the main thing you'll see here is that we are temporarily using this as kind of a transitional collection. It's not a complete graph per se, but it gets the job done quick and dirty. So we have a string which represents a city, and each key, its value is an array of strings, which kind of makes sense. So we are going to read in this file and temporarily store it. This will be the key, and then this will be an array of strings. And that's just a temporary collection we use to load the graph. And I will show you how to use a third-party library to make this a lot easier. So the code really isn't that complicated for how to read in the text file. If you go back to some of our earlier modules, you'll recognize some of the methods I use, but I tried to do good object-oriented design by sticking a lot of this in a different class called AnyTextReader. And the idea is, oh, I do need to update that. The idea is this class, you could use it for any project because the values aren't hard-coded at all. all you need to use this AnyText reader is a string array. This is funky syntax, but it's just another, it's called the var args syntax, which lets you accept any amount of strings, kind of like an array. It's very common, more common in Python, but yeah, I use it for some things. Like in this case, you could have one folder name, or if you have nested directories, you might need multiple path names. So you have to enter all of the folders in which the text file is. So in our case, if we start at the root, we're in the project root graph demo, and to get to the input text file, we have to go through edu vwcc graph demo. So this actually isn't going to work because my package names are all out of whack right now. So let me fix that real quick. And this will show you what you all will need to do. So you do need to update these values here, but they're not, you shouldn't need to change anything in this file except this. Or I'll do it for you before I post the jar. Let's update all these package names. Graph helper. Save all. And so the AnyText reader just uses the files API, which I like, read all lines, which accepts a file path object, and returns a list of strings. So that is how I get this text file input as a list of strings. And then I need to do some text processing on that list of strings, which I do here in the read text method. So no surprises here. But then I'd populate the map using map.put with the key value like Roanoke. And to get the array of strings, I'm just splitting the rest of the string on the comma and a space. So this actually stores, if you wanted to see what this actually stores in the value, the array of strings, it would be like this would be at index 0, this would be at index 1, index 2, and so on. That's what the array of strings is. Okay, and then so if you ran this program, you would bump into a complication, which is that we are using a third-party library to actually compose the graph. So after we call read text file, I have this other custom class called graph helper, and I feed that new map that we just made into the graph helper. And then graph helper has a bunch of imports from a third-party library. And that's because somebody has already solved our problem. And it is a common best practice as a developer to use widely tested, well-established, recognized API libraries. And the one I'm using is JGraphT. And you'll wonder, but isn't that cheating? You know, didn't we have to write the code ourselves? And the answer to this assignment is no, you did not have to actually create your own graph data structure or your own implementation of Dijkstra's algorithm. If you did, that's awesome, and I will give you kudos when you submit it. But I wanted to show you how, developers on the job in industry would tackle this sort of thing. Not by writing everything from scratch, but by using a well-recognized, trusted third-party library. So we ran the code and it failed. So the question is, how can we fix that so that you can see how to actually make your own graph, like in this code, using this third-party library? And we are just using a class in our third-party library called Simple Weighted Graph to make that. Okay, so let me show you all where we get the library from. This is the home page for JGraphT. As it says, a Java library of graph theory, data structures, and algorithms. And the way you learn how to use libraries like this is by reading the documentation and going through, this demo that they provide. So you learn more about the library to see if it works for your use case. You learn how to install it, and it recommends using Maven. So I might show you how to do that at the end of this video, but I want to show you an easier way. That's also considered the older way. I only call it easier. It's not actually easier once you become better or more familiar with Maven. If you do start using Maven, you'll see that Maven actually makes things a lot easier ultimately, but for what we're doing in this module, we don't need to learn a whole new technology. So we're not going to use Maven. Instead, we just want to download the library as a jar file. So let's go to download. And well, it doesn't provide a jar, so let's download this zip and see what's in it. And it does give you some instructions that are helpful. And also, if you want to learn more about how to use the entire library, you would go through the user guide, the README, there's a wiki. So I mean, this is just how you learn like a new class library or API. So we will download the zip file, and actually I already have, so I'm going to cancel that. That's my Maven. I was looking at the Maven question. And I might come back to this to show you this a bit later. I was going to show you all a little bit about working with Git and GitHub as another alternative too, but we are running out of time, so let's just go to, let me pull it over. Okay, so that will download a zip file that you can extract, and it'll automatically give you the latest version, 1.5.2. So it's like, where do you get the library files that you need? So you have to like hunt through these folders. It's probably not JavaDoc. That's probably great stuff, but yeah, these are more like documentation elements. But we just want the files from this lib folder, and you would have to read, the online documentation to figure out which of these you need. Again, Maven would handle some of this automatically, but not a bad idea to just start with JGraphT core and see what else we need from there. And I know in advance that we are only going to need 2 of these jar files to add to our project. We're going to need this core one, which has all the basic functionality, and JHeaps, which is part of the implementation details that we don't need to know about since we're just using the Graph API in our code. So let's go ahead and, not sure why I always this does this. Let's see if we can configure the build path. I'm just going to have to back out one level momentarily. Click on the project folder and then go to build path, configure build path. Go to your libraries tab and then class path, and we're going to add our external jars. Like we said, we just need core, and we're going to need heaps. So I'm going to select class path again, and this time find JHeaps, and then we will apply and close. And you notice all of the red imports are now recognized. So that's how you add, a third-party external, that's how you add a third-party library to your project using external jars rather than using Maven. And if you wanted to read the documentation, you will learn that this is just how graphs are created using JGraphT. So you have to specify a node type right here. Each graph does fully work with generics, so your node type could be any object. There's a lot of possibilities there. You could create like airport classes, and that airport class could be your node type. I'm just using string because all we really need to store is the name of the city as our nodes or vertexes. And then we just need a weighted edge. We don't need a directed edge. So I'm using default weighted edge, which is another class that JGraphT provides. And the constructor is kind of weird looking, but it just accepts a class file of whatever edge you need in your graph. So we're just creating a new simple weighted graph, and we have to feed it this class file of whatever edge we choose to use. And the rest of this is code I wrote to handle the menu options. So this is a constructor. The graph helper constructor loads the graph automatically from the city map that we already created from the text file. So as soon as we create a graph helper, we have a new graph with all the data populated already. And then data summary, you can do this however you would like. I just wanted to show some basic information about the graph. And so like I show number of cities, number of connections, total number of miles, average distance between cities. Is the graph fully connected? So is every vertex connected to the graph, or are there any isolated vertexes that are separate from the rest of the graph? And most of this is not new. The only thing new here is to determine whether a graph is fully connected. We're using a different API from JGraphT called this connectivity inspector, which does the work for us. So yeah, it kind of feels like cheating because we're not writing all the algorithms from scratch ourselves, which you could do, to answer this question, but we're saving a lot of time and effort by using the API. And that's going to be true with find shortest path. Instead of writing Dijkstra's algorithm, or if you were exploring other options like A star, you could have tried to write it out by scratch, and some of the material in Canvas goes over the actual steps of Dijkstra's algorithm. But once we've imported JGraphT, we can let it do the heavy lifting for us just by creating this Dijkstra shortest path class and initializing it. So all we need to do is give it our populated graph and call get path based on the source city and the target city. And if that returns null, there's no path between the two cities. Otherwise, we can see what the shortest path is using this class just by, alright, so this creates a shortest path, and then we're going to print out that shortest path. And I use a stream to do that because this is basically just a list of strings. At least it will be once we call get vertex list. Okay, so let's give this a little run through. Very simple menu, and before this menu even loads, we've already populated our graph. So let's take a look at it. I'm going to do option 2 first. And this is just how I decided to visually represent the graph. I actually used the map to print this out, but you could use JGraphT instead. It's really up to you. And you might not, I don't even think you need to do this for your submission, but you do need some sort of data summary. And this shows you how many cities are in the text file, and the number of roads, the total number of miles in the graph in terms of road mileage, road distances, the average distance between cities, and every vertex is connected. So last but not least, let's calculate the shortest path between two cities. And I don't know about you, but I'm ready to go to Virginia Beach. So let's go to Virginia Beach, and we'll start from Roanoke. Or let's make this a little more interesting. Let's start from Radford. So we see the shortest path between Virginia Beach and Radford is Virginia Beach, Norfolk, Richmond, Roanoke, Christiansburg, Radford. And the total distance is 291 miles. Cool. So yeah, we could pick any two cities. Let's say we want to go to, let's go to Arlington from Blacksburg. So the start city comes first. Arlington. So this has us going through Roanoke, through Stanton, Harrisonburg, Winchester, and Arlington. Which, yeah, that fits with my mental map of the interstates in Virginia. So anyway, this is just a cool little demo. It should help you get further along with the graph assignment. I think you would be able to, edit this code pretty easily using the different data set to complete the assignment. And I know I said I would talk a little bit about Maven or GitHub, but the video is already pretty long, so that stuff is really kind of optional. If you're interested in learning more about it, send me an email and I can hook you up. So, alright, take care everybody. It's been a privilege.